going to see a new topic called kernel. So you might have seen this particular topic in the previous classes that I talk about kernel, what is the kernel and how it is related to the operating system that we'll see today. So what we know about operating system till now. So we know that this operating system is some sort of system software that manages computer hardware and software resources and provide common service for computer programs. So that is the work of the operating system. It manages our computer hardware and other software resources. So as well as it provides the services for the computer programs. So what are the services that is there? Like for the computer programs, it will provide, like if a computer program need the IO device, so it will provide those IO devices. If a computer program need a platform to run, it will provide a platform for that. Or if a computer program need to process, it will give the resources like RAM. First, it will be given to the RAM, that is your main memory, and from the main memory, your program will be reached to the CPU, and in CPU processing will be done, and again come back and given the result into the console. So all these management and all these resource allocations will be done by the operating system. And these operating system, we say it is a system software. We cannot say it is an application software, because application software, we know what is application software is. So the application softwares are, let's say you have purchased a new laptop, and in that particular new laptop, we find out that we have essential software which is related to the operating system, and then we have to install, let's say if we want that I want Microsoft Word or this Microsoft Office to install, so I'll install Microsoft Office. If let's say I need another type of browser, so I'll install other type of browsers other than the operating system specific browser. Let's say I want to install some sort of media player. Let's say I want to install some sort of system software which may connect to my printer, right? So all those applications, software that we have to install, and different device driver we have to install for using. So that is other type of software. The operating system, generally it is called system software, okay? Because actually it manages your computer, it manages your system. So that's why the name is system software. And there is an application software, right? So in the application software, actually we interact directly with the application software. And these application software is a media by which we interact with the hardware through the operating system. So the application software will be interacting with these system software, and these system software will interact with the hardware. This is how the process goes on. So if we'll talk about, we'll go through this later on, the diagram of it, we'll see it. Now the system software, collectively called operating system, which manages your computer. That is that we know from this particular definition, that what is an operating system. So an operating system is nothing but system software that manages computers, hardware, software resources, and provide common services for computer programs. Now let's go to the kernel. That what is a kernel? Kernel is the most internal services are provided by the kernel. Now what do you mean by internal services? So the meaning of internal services are, let's say if a program need the platform, or program need some resources to run, so these resources will be provided by the kernel. If two processes want to communicate with each other, inter-process communication, that is also done by the kernel. If program need to be load into the main memory. So the management of the main memory, that is also done by the kernel. So these are internal services that is done by the kernels, and these internal services contain most important operating system processing functions. So we know what operating system will do and the kernel will do. So that's why we say, because this kernel is doing most of the internal services work, so we say that this kernel is nothing but core of the operating system, or central module, or the part of the operating system, or central part of the operating system. Because actually there is a kernel which is a part of the operating system which will do all those things: managing resources, managing the CPU, managing different hardware, interact with other hardwares. So all these things will be done by the kernels. Remaining services are provided by other modules, and that module also controlled by the kernel. Remaining services means, let's say we have we have purchased a new hardware, and let's say we have purchased a scanner, okay, and I want that my system should be connect with the scanner. So what I'll do is I'll connect the scanner and I'll try to install the device driver of the scanner. So this device driver is not the part of the operating system, right? This device driver is an external software that we have installed. And so this device driver is also doing the services, internal services, because it is a hardware, and that could not be done by the kernel. But yes, kernel will manages it. Kernel manages uh, all these device drivers, what we have. If it is not the part of the operating system, if we are installing it outside the operating system, so definitely controller will kernel will manage all those different modules or different device drivers that we install. So what is the definition of the kernel? So with the aid of firmware and device driver, with the aid of, right, firmware and device driver, the kernel provide the most basic level of control over all the computer hardware devices. It manages memory access for program in the RAM. It determines which program get access to which hardware resources. It sets up or reset CPU operating state for optimal operation at all time, and it organizes the data for long-term non-volatile storage with file systems on such media such as disk, tape, flash memory, and all. Now, what it will do? So it is written here what it will do. So with the add of firmware and device driver, what is the meaning of firmware? So firmware is a sort of software or sort of dedicated software that is attached to a specific hardware, that is called firmware. Like if we'll take an example of a remote control. So remote control is a hardware, right? And there are many buttons in the remote control, but that remote control will be run by some sort of software, and that software is called firmware. This The firmware is nothing but it attached with a specific hardware, just like your embedded system. So what is an embedded system? There is a hardware and the dedicated software to that hardware. If we are making a combination of hardware and the dedicated software related to the hardware, that is called embedded system. And this firmware is also is the software of that particular hardware. Device drivers, we know what is device driver. Device drivers uh, are the software which will help to access the hardware, and it has all the functionality related to the hardware. So device driver is also specific to the hardware. So with the add of firmware and device driver, The kernel provides the most basic level of control over all the computer hardwares, right? All the computer hardware. So we have internal hardware, which will be managed by the firmware, and we have external hardware, which will be managed by the device drivers. So both will be managed by the kernel. So kernel will decide that which particular device driver has to call at what particular time, and which particular process has to be served by these hardware. So it is managed by that. So it manages memory access for program in the RAM also. In the main memory, uh, how this program be used will be using the memory access. That is also done by the kernel. It determines which program get access to which hardware resources, right? Hardware resources like your RAM is a hardware, right? So how this program will get the RAM, how this program will get the CPU, all these will be managed by the kernel. It set up or reset the CPU operating state. There are mainly two states of CPU. One is state that CPU work in a user mode or CPU work in a supervisor mode. So there are two modes, user mode and supervisor mode. And to manage these two modes, there is an interface called kernel mode. Okay, and through the kernel only, the CPU will be deciding that in which mode it is going to run, whether it is running in the user mode or it is running in the supervisor mode. So when okay, we'll see what is different modes are. Here we'll not discuss it. It organizes the data for long-term non-volatile storage. Means it manages the data also in the hard drives or in the your solid state drive or your pen drive, flash memory, or your tapes, right? Through the help of file systems. So we know that every operating system is related to some sort of file systems, that how we are going to manage the directory and how we are going to manage the files. So that is also done by the managed by the kernel. Let's go to different services related to the kernel. So the first service which is related to the kernel is program execution and process management. How a program is going to execute in the system, means with the help of these CPU, with the help of these RAM, how it will be done, as well as how this program is going to execute. So both the thing will be done by the kernel. Then we have a concept of interrupt handling. We'll see in upcoming classes. Maybe in the next topic, we'll learn about the interrupt. There are different type of interrupt that will be managed by the kernel only. Different type of interrupt means we have hardware interrupt and we have software interrupt. The interrupt caused by the hardware means, let's say with the keystroke or with the mouse stroke, if you are sending some signals like we have seen in the register, we have IO register. So this IO register is for hardware interrupt. Or we have software interrupt. Any software is looking for any, let's say, if we are having a software and we are making a software which is taking the input from the user. So what will happen is the software will run and suddenly it will be interrupted and it need the console. So what CPU will do? CPU will see that this particular, right now there is a printf statement. So right now we have to provide the hardware to it. So that type of interrupt is called software interrupt. We'll see in detail different type of hardware interrupt and different type of software interrupt and how this kernel is going to manage it. Then kernel will manage the modes also. Just now I told you we have two type of mode in the CPU. We have user mode and we have supervisor mode. This supervisor mode will be used when we are running any system software. It means any program related to the operating system. So at that particular time, we have to change the mode to supervisor mode. And there is a user mode. User mode means in the user mode, user will have the control and it will run their softwares, application softwares in the user mode. So these two are the mode of the CPU, and the interface, or you can say the bridge between user mode to change to the supervisory mode, it will be done by the kernel. Memory management, here it is talking about RAM, random access memory management, how it will be done. Then there is a concept of virtual memory. What is a virtual memory? Virtual, we know that it is not real, right? It is not physical. So let's say we have 4 GB of memory and my program need, let's say, 8 GB of memory. Can we serve it? So yes, with the help of operating system, which has the capacity of the kernel to manage that, we can run even 8 GB of program with 4 GB of RAM. Because with the von Neumann architecture, we know that every program should be there in the main memory, right? So if a program is of 8 GB, how we can accommodate in 4 GB? That concept will be taken by the virtual memory. So we'll make a feel to the user that your 8 GB is also accommodated by my 4 GB RAM, because there is a concept of you can say demand paging. So whenever we need some sort of page from the program, we just get it from the secondary memory to the main memory, and that will be done very fast, and that will be managed by the kernel. So all the program we doesn't have to put into the RAM. Instead, we'll put the portion of the program which is required right now. So that concept is called virtual memory. Means user will feel that there are enough memory is there with the program to manage. Then there is a concept of multitasking. That is a part of process management, that how multiple process will be managed and multiple tasks would be done. And it is also a part of CPU management, that how a CPU will be managed in such a way so that multiple tasks will be run into the CPU. That is also done by the kernel. Then there is a disk access and file system management. We know that every operating system has different file system. We know Windows, previously we have FAT32, right? And then in the Windows there is NTFS. If we'll talk about Linux, there are x83, 86 type of file systems, and that is called VX6 file system. So all those are different type of file system which are there with different operating system, and these operating system will manage those file system. File system is nothing but a provision in which how we are managing the directories and how we are managing the files will be taken care by the kernel. What are the kernel usage? We have seen that, but just will revise it. It will allocate space to the program which needed. Where it will allocate the resource space? In the RAM, in the main memory. Okay, in the main memory, it is going to give the spaces to the program. Schedule time to execute the application. It will manage the CPU. How CPU will be scheduled by these applications. Provide communication between program that has been taken. That concept is called inter-process communication, IPC. That how two program can communicate to each other. Program security to other module and the services. Will provide the security to the program modules and different services, and that security provision will be done by the kernel, that which particular program will run in which particular mode. That will be done by the kernel only. So mainly we have two type of kernel exist. The first kernel is called monolithic kernel and the second kernel is called micro kernel. Now what is the monolithic kernel? That we'll see first. So in the monolithic kernel, all operating system services run along with the main kernel threads. So there are only one thread of the main kernel and all the services will run by the main thread or main, you can say, main module of the kernel. So there is only one module of the kernel, and in that particular one module, lots of things are there related to the operating systems. Thus, all thus also residing in the same memory space, memory area. So you can see that different functionality which we have just seen that what kernel can do, all the thing will be managed by one program. So let's say there are 10,000, 20,000 line of code in which we have the provision that how will manage the program, how will manage the CPU, how will manage the memory, how will manage the file system, how this device driver is going to be managed, how we are managing the hardware, all the thing will be written in one big program. And this one big program will taken as a kernel. And all these things will be done in the same memory space. So there are two memory spaces, user memory and the system memory. So there are the spaces where user program is going to run and system program is going to run. So system program is nothing but your kernel or your operating system. So from the system program, also from the application program, also it has taken the area of, to the system program. So all the thing will be run in a supervisor mode. We doesn't require the user mode. So that is happening in the monolithic kernel. Means all the thing will be written in one particular program. This approach provides rich and powerful hardware access because all the thing will be run by the supervisor mode. We doesn't have to change the mode all the time. So easily a program will get the hardware, easily a program will get different type of device driver to manage. So it doesn't have to change the mode. And see, always you remember that whenever we want to change the mode from user to supervisor or supervisor to user, we need some sort of interrupt. An interrupt is required and it will take time. Let's say if I am in the user mode and I want suddenly I need some sort of hardware, I need to change the mode from user to the supervisor mode. To handling the interrupt, it will take time, right? And to managing the interrupt, it is also taking time. But here what will happen is everything is running in the same mode or same area like supervisor mode. So we doesn't have to change it frequently and it will be very fast because everything is there in one program. I don't have to go and see whether the device driver is there or not or what type of firmware we are using or there are many other things that are there, right? So we'll see that. Some developer such as Unix developer, which is the developer of the Unix is Ken Thompson. Ken Thompson, I told you about, he's a white hat hacker. White hat hacker means the hacker with ethical hacker. Ethical hacker comes under white hat hacker. So this Ken Thompson has done research on Windows operating system, and they will find out that there are many flaws and there many problem related to different type of problem related to viruses and different hacking. So they have, so he has developed a kernel which is called Unix kernel, and this particular Unix kernel, what he has developed is developed monolithic kernel. Means all the thing will be done in once in a one package. So and it says that it is more secure. So now in today's Unix software or Unix like software like Linux software, we see that it is more secure than the Windows operating system, related to hacking, related to what viruses and all. So, such as Unix developer, Ken Thompson maintained that it is easier to implement a monolithic kernel than microkernel. So, what it find out that it is easy to make one program instead of a small program of a kernel, and this kernel will manage the other programs like other device drivers and other functionality of the operating system from the outside. Instead, all the things should be managed inside one program. So it find out that it is easier to implement monolithic kernel. The main disadvantage of monolithic kernel are the dependencies between system components. So definitely, if you are making one program and you are looking for, let's say, at one time you are looking for managing the CPU, and the same time you are looking for managing the main memory, and both the program are there in one particular big program or big kernel, monolithic kernel program. So definitely to find it out and to manage all those things, it is very difficult. So it says that this is the disadvantage, because the interdependency will be increasing because they are one program and definitely they are dependent. A bug in the device driver might crash the entire system. So as I told you that a monolithic kernel has all the thing involved in one particular program. If we finding bug in any of the programs, so my whole kernel is going to crash, or my whole operating system is going to crash. So that is a problem related to the monolithic kernel, because all the program are dependent, they are not independent, in the fact that large kernel can become very difficult to maintain. So the examples is in today's Linux is one example you can see. And there is mm, BSD, that is Berkeley Software Distribution. That is also a type of operating system where monolithic kernel has been used. Then in previous version of Windows 95, 98, monolithic kernel has been used. Okay, now look, let's go to the microkernel. What is a microkernel is also abbreviation as MuK. Is the term describe an approach to operating systems designed by which the functionality of the system is moved out of the traditional kernel into a set of servers that communicate to the minimal kernel. So here is the concept of minimal kernel, means the kernel size has to be reduced in such a way so that all other component will be independent and all other component will be managed independently, leaving a little as possible in the system space. So system space is very little, means your the space where only system software is there, that space is very less, as much as possible with the user space, and the user space is bigger at that particular micro kernel. So here the concept is we'll make a minimal kernel, and this minimal kernel is going to manage each and every component of the operating system. That is a concept of microkernel. The microkernel that is designed for a specific platform or device is only ever going to have what it need to operate. There is some example of microkernel like Mac OS, Windows NT, which is a network version of OS, or Minix 3, that is also a type of microkernel. Now let's see the difference between these two with the help of a diagram. So you see this is a microkernel where this is the kernel part. So you see there are only basic inter-process communication part is there. Then virtual memory, how virtual memory is going to manage, that part is there, and scheduling part is there. Scheduling will be the CPU schedule and your disk schedule. So only these part is there with the kernel, and other parts like application, interprocess communication, Unix server, device driver, and the file servers all are independent module here, and they are running in the user space. Now, if we'll talk about monolithic kernel, then all these things like device driver or dispatcher, scheduler of the virtual memory, inter-process communication in the file system, virtual file system, and your system calls, all those things will be there in a one program, and all these are the part of the kernel in a monolithic kernel, and all these are running in the kernel space or system space. Okay. And whenever we require, let's say we are managing the file system, so we have to go to the kernel mode or the supervisor mode, and here it is outside it, but definitely the kernel is going to manage this. The management will be done by the kernel, but now they are the separate entities in the monolithic kernel. So you see, what are the advantages in the monolithic kernel? Your kernel size is very small, so definitely we doesn't have to waste the memory space of the RAM. Let's say my RAM is 4 GB. So generally what will happen is 1 GB will accommodate for the operating system. But in the monolithic kernel, it will be of MB. So only small MB, 1 MB or 2 MB space will be taken off the RAM for the operating system. So, and you can see that when your system boots, after the booting, this is the program, the kernel that will be there in your RAM, and it will run up to you are shutting down your system. So this kernel will be there always in your RAM. So if you think that your RAM space is very less, so don't use the monolithic kernel. Instead, use the micro kernel. The advantages are these application IPC, these Unix server, these device driver, and these file servers we can manage independently. If you want to add something, you can add it. If you want to correct something, you can correct it. So all these, because all these modules are independent, so management will be very easy. But here it is a part of the kernel, so we cannot change the kernel actually, right? It will be changed only when we install another version of the operating system or the new version of the operating system. Then only it is going to change. Otherwise, it is not going to change. If something goes wrong with the file system, if something goes wrong with the process communication or some sort of device driver, then this monolithic kernel is going to crash. And see how it is connected. Like your application programs are there. Through the application program, you can able to communicate with the kernel, and these kernel will run, because they are system software, it will run in a supervisor mode, and then it will interact with the hardware. So you see that how this interface will be taking place. That's why it is the kernel is in between the application and the hardware, or you can say the software and the hardware. So this is your kernel, and we have seen different functionality of the kernel, how it is working, different types of kernel. So I think this concept is clear to all of you.